Next, we have Steve Wilkes from Stream.
Good morning, everyone. Hope you're enjoying the show. So I'm not going to talk about our whole platform today. You can come and talk to us over there if you want to hear more. I'm just going to really talk about change data capture and how important it is for in-memory computing. So hands up, who has enterprise applications in their enterprise? Yeah, most of you probably. And these enterprise applications, they run on databases. So every change that happens in the application, every update, that's going to update some database. It's going to create a record. Now, most people don't think of databases as something that goes really well with in-memory computing. Databases are really a record of what's happened in the past. They're not a record of what's happening right now. So how do you tap into the database information in order to get it into in-memory computing and make it work at the speeds that in-memory computing can work at? So is anyone interested in this kind of thing, or am I just wasting my time? Hands up? Okay, good. We've got some people. And the reason you may want to process it in memory is because you want to create some results. You want to put those results somewhere else. In-memory computing can do a lot of processing of data. It can do a lot of analysis of data. It can do merging of data and do all of this in real time. But if databases are this static record of what's happened, how do you push it out onto Kafka, for example, or other message queuing systems? How do you deliver it into the cloud and have your cloud completely up to date? How do you make sure that your data lake in Hadoop is up to date? And so to answer these questions, let's look at some of the ways that we can possibly get the data out of the database and into your in-memory computing platform. So can we use SQL queries? Probably not. If you have production databases and they're running enterprise applications, most DBAs are not going to let you run large-scale queries against those databases because these queries could affect the performance of a production database. So what can happen is they can suggest using a replica. So instead of going against the production database, you can run these queries against a replica of the production database. Now, you're not going to affect the performance of the production database at all, but doing that is pretty expensive. You require not just a copy of the database, so extra hardware, extra database software, extra licenses for your Oracle or SQL Server database, and you need the software that can actually move the data from your database into your replica. So we strongly recommend using change data capture. And change data capture is an approach that enables non-intrusive collection of database change in a streaming fashion, in a real-time fashion that is really in keeping with the spirit of in-memory computing. So how does change data capture work? Well, databases write all the operations that are going on in the database into a transaction log. All of the updates, deletes, they're all recorded in this log, so if the database crashes, it enables it to recover, and for other kind of bookkeeping purposes, etc. So change data capture reads from this log. It's going to take the data from this log as it's written, and if you're using a in-memory platform that does this right, it's going to generate real-time events on that data, on those changes. So that means that all the DML operations against the database, all the inserts, updates, and deletes that are occurring, they will be written to the transaction log where they're captured by change data capture and then pushed out into your in-memory computing framework as events. And once they're in the in-memory computing framework, you can do what you want with them. So can you just use CDC? Do you actually need to process this data at all? Well, you can, but in certain use cases, the CDC data really needs to be processed before it's useful. So this basically means, an example, most enterprise databases are highly normalized, right? The whole bunch of tables, the tables have a whole bunch of IDs in them. You have your customer table, and your customer table has customer ID referencing it. But if you have like something that represents, has a customer purchased a certain service, right? That table's going to have a customer ID, it's going to have a service ID, it's going to have a status ID, a whole bunch of IDs. So if you push that raw change into Kafka or into your data lake, what do you have? You have a whole bunch of IDs, which isn't particularly useful because it's going to be hard to query on that. If you want to ask a question like, what are my top 10 customers in California doing right now? You can't do that against a bunch of IDs. So that means you probably need to do some kind of in-memory processing in order to actually make that data useful. The first thing you can do is you can filter out unnecessary data. You can transform the data into a format that you want. It's all the kind of processing that you can do in memory. You can start using something like windows, like data windows over the streaming data that's coming in. And that will allow you to do things like aggregation, or remove redundancy, or look for trends over time. Think 5-minute moving average. And these are the things that in-memory computing is really good at. Most importantly, you can enrich the streaming data with additional context. So load huge amounts of data into memory and pass the streaming change data through it and enrich it as it's flowing through. So now that customer ID becomes a full customer reference, you write it out, it's now useful. So obviously, if you want to do this at scale, then you need to be able to partition your platform so that you can do this over a large cluster, so that you can use sharding of data. And that means that you have to make sure that the way that you shard your in-memory data for enrichment matches the way you shard the events that you're throwing through at high speed. And then you can join it because the joins are local in memory and they run really fast. There are lots of additional things that you can do with change data. And we have sample applications that we're running over in the booth. You can see some of the things you can do with change data. You can start to search for patterns. So run complex event processing on that change data. Look for interesting things happening over time. You can look for anomalies, anything unusual. This can be at the data level. It can even be at the table level. Are there more operations happening on a table than usual? And is that an issue? Or are there less happening than usual? That could be an issue as well. At the data level, you may want to say, is any one product that I'm selling more than it usually does? In which case, you may want to look at the price of it. It may have been priced incorrectly. You can correlate things in space and time. So you could do some of the geolocation type of mapping. You can do time mapping. If something happens in a database, was there something going on in the web server at the same time? So those are the kind of correlations you can do in time and space. And then, of course, you can build things on top of that. You can visualize things. You can analyze things. You can trigger alerts so that people can understand what's happening immediately. One of the issues with databases is there's no real alerting on what's going on. All of the alerting is at the application level. By tapping into your database and by understanding what's happening in real time, if you see something unusual going on, then you can alert on that immediately, so to push someone to actually go and analyze it and see what's happening. And we have an example of that in our booth where you can see these alerts happening on unusual behavior. And then you can automate triggering other workflows. So instead of alerting a person who may not be awake, you can trigger an automated workflow in order to actually do something important. So that's just a sample of some of the things that you could possibly do. And it just so happens that our platform does all of these. But I'm not here to pitch the platform. I'm here to tell you that you should really think about change data capture. So one thing to remember, and I have 1 minute to go, so I'll say this really slowly. Change data capture and the streaming integration, the in-memory computing that can go with it, should be part of your in-memory computing and enterprise data strategy. If you just use change data capture by itself, then you lose a lot in the kind of processing you can do and the kind of insights that you can gain on that data in real time. If you just use streaming integration in memory computing by itself and you don't harness the potential that's lying around in your enterprise databases, then you're missing out as well. So you really need to put the two together. So as I said, if you want to know more, come over and talk to us in the Stream booth, or you can go to our website. email me, tweet me, whatever. Thank you. It's been a wonderful audience.